Thank you, Kostas. Good. All right, we have a new word. I also want to reiterate. I think this is exactly the mission of this university. And in fact, Berkeley, I think, is outstanding in this direction of bringing together multiple disciplines, which is another sense of inclusivity that we haven't talked about so much today. Well, our next speaker is James Manyika. He is a director. He's the director of the McKinsey Global Institute, where he does research on the global economy, including growth, productivity, competitiveness, digital economy, automation, and the future of work. I also am proud to say that we have something in common, in that we were both born on the continent of Africa. James.
Thank you. Thank you, Ken. I'm delighted to be here. We're just going to pull up some slides. Ken encouraged me to talk about some of the work we've been doing looking at the question of the impacts of AI automation on jobs and productivity. And I'm going to draw from some of the work we've been doing. But a couple things first. As an engineer, so I did my PhD 20 years ago in AI and robotics before it became interesting. No, but seriously, I think one thing that's been quite striking is that in the last 5 or 6 or 8 years, we've made amazing progress on the technology, whether it's robotics, AI, machine learning, deep learning. The progress has just been amazing breakthrough. I think it's also the case, now that I spend my time thinking about the economy and business, that it is the case, and a case can be made, that this is actually good for businesses. They'll become more efficient, more productive, and it's also good for the economy. Because we know that if you look at the long history of economic growth, it actually matters that we have productivity. Productivity matters for economic growth, and we know that these technologies will contribute to economic growth. So I'm not going to make the first or the second case in this discussion. I want to focus my remarks on the last point, which is, what about jobs? Knowing that we know that there's some good things that will come out of the first 2 points on the page. So what about jobs? Well, first of all, right now, there's a lot of studies out there that are looking at the question of impact on jobs. And I think one way to think about these studies that are out there, and this is just a sampling of them, they roughly fall into 2 categories. I think there's one group of studies, and the Frey and Osborne work is a good example of that, where people have taken an occupational view. They've looked at jobs and looked at the question of to what extent can this job be automated or not. We're probably at the other end of the spectrum here, maybe somewhat similar to the work that the OECD has been doing, where we've taken a different approach. We've tried to understand what happens at the task and activity level. And the reason for thinking about it that way is we know that most activities and occupations or jobs that any of us do consist of multiple activities. And some of those are, any one of our occupations, there are 20, 30 different tasks that we do that make up that occupation. Some of those are more automatable than others. So that's the approach that we've taken. And I want to make a couple points about some of the insights that have come from that work. And I may come back to this chart. Let me describe 3 things that we've done. First was we've taken a look at something like 2,000 activities that happen in the economy. Think of an activity as something like data gathering, analysis, and at the level of kind of 2,000 activities. We know how that relates to the roughly 800 or so occupations in the BLS data set that classifies occupations. We've also done a third thing, which is to look at what are the capabilities required to do those tasks. We know that some of those capabilities are mechanical, so you have to be kind of manual dexterity to be able to move and manipulate things. There's a whole bunch of things that are physical capabilities of that form. We also have motor skills and so forth. We know that there's some capabilities that are more cognitive, the ability to calculate things, the ability to recognize and make inferences and so forth. We also know that there's some abilities that have to do with kind of being able to sense things and intuit things. So there's something like the 18 capabilities that we've looked at. Then we've also looked at what can technology do today, currently demonstrated capabilities across all of those, to understand, are we closer to matching human capability with what we can demonstrate today? So we're not looking at things that are 40 years out, but things that are demonstrable today to get a sense of what's easy to automate or not. So if you take that approach, what we found is that, and this is a grouping of the kinds of activities that we've looked at, and we haven't got to jobs yet, this is just activities. We find that and we grouped them into roughly these 8 categories. There's a whole bunch of activities that you might call managing expertise, interface, and working in very unpredictable physical environments. Those are actually very difficult to automate, technically, as a technical question. Can machines do that or not? Those are actually relatively difficult. Whereas there's a bunch of things at the far right of this chart that actually technically, as a technical question, are easier to automate. So things that involve collecting data in one form or another, things that involve processing data, things that involve doing physical work but in highly predictable environments. So think of an assembly line, for example. That's a very highly predictable environment. You can arrange things to be where you want them to be, the lighting to be what you want it to be, and so forth. So what you see in this chart is that whenever those activities on the right are prevalent in occupations, those are relatively easy to automate. And when you look at that in the context of the US economy, those activities in the economy, again, not jobs, activities, they make up something like 51% of activities we pay wages for. So that's a big number. This is activities. So then you can ask the question, how do those activities map to sectors? What's the density, if you like, of those activities? As you can see, I guess some of this is included by the chairs. There's some sectors up at the top where the density of the oranges and the reds and so forth are more dense than others. By the way, the report that has all this stuff is available. Happy to circulate it. But you'll see that there's some sectors where the activities have a high density. So places like mining, retail, transportation. So the people worry about the truck drivers. I think that's a reasonable worry. Truck drivers, manufacturing, and so forth. Whereas there's some sectors down at the bottom where the density is not quite as high of the easily automated activities. You can ask the question, so does that mean all jobs then get automated, which is one of the questions that's out there. Well, if you look at the activity level, you get a slightly different view. So if you say, so which occupations have almost all of the activities that they do in that occupation that are automatable? The conclusion is actually not a very large number. So we conclude that it is based on current technologies today, that number from our analysis looks more like 5%. The OECD, when they've done a slightly similar, methodologically similar analysis with slightly different data sets, they get to a number that's more like 8 or 9%. In terms of whole jobs where the entire activities associated with that occupation get automated. But there's also something else that's interesting, which is that there are many occupations, and that's roughly indicated by what's boxed here, where the punchline is something like 60% of occupations have something like 30% of the activities in those occupations that are automatable. So what does that actually mean? What that actually means is that in addition to worrying about jobs that may or may not go away, which is, by our estimate on current technologies, about 5-ish% for now anyway, there's a bigger question, which is people are going to be working with machines a lot more. So that if part of my occupation has a big chunk of what I do that's automated, and we're going to have more and more occupations look like that, we're going to have to think through how do people work with machines, and how do we enable that and make that easy. But that also raises a whole bunch of questions that I think Laura may even touch on that may or may not have wage and income implications. We know that when people work with machines, in highly skilled environments where the machine is doing the complicated part and the human is still also doing the complicated part, that's actually a win-win, by and large. But if you have it the other way, where the machine is doing the hard part and the human is doing what's left over, and there's a large labor supply for those activities, and the skills are not very high, that can put pressure on wages. So the question of what happens when people work with machines is a very interesting one, and we're probably going to see more of that than, at least in the near term, that we will see jobs disappearing altogether. We map this back to occupations. There's a fun chart. What it basically says, each of these dots is an occupation, and we're trying to understand, so which occupations have all of their tasks that are easily automated versus which ones have very few. And what's interesting is that you can see there's some occupations, e.g. file clerks, that are high up on the automatable end of the spectrum, whereas gardeners are relatively low, which is interesting. And so the presumption that it's only the low-skilled jobs that will be automated the easiest is not that straightforward. and you can see where CEOs and other people show up. I'll end up with this chart, and this is to say one of the limitations of much of the work that's been done so far, including our own, is that most of us are asking the first question, which is the technical feasibility question. But we think the actual question is when and how much automation will we see depends on a whole bunch of other things. It depends on, so what will these technologies actually cost to deploy? How does that play into the labor market supply-demand dynamics and the quality of the labor? What about the actual benefits that go beyond just simply labor substitutions that come from this? And what is the response of the regulatory and other social acceptance factors? The reason it's important to think about these other things is, by analogy, if you think about electric vehicles, when was it that we demonstrated that electric vehicles were possible? That was more like 45 years ago. So the technical feasibility for electric vehicles, which is this question, we established that maybe like 45 years ago. But it's taken a whole bunch of these kinds of considerations for them to actually show up on the street, which is roughly about now. So we shouldn't get, the point is, in addition to thinking about the technical feasibility question, maybe getting freaked out by that, let's make sure we also think about some of the other considerations if you look at the history of how technology